Our bottleneck is focused on verifying if the selected processes can achieve the dimensions and tolerances mentioned from research literature. Namely, we intend to prototype laser cutting, CNC machining, and injection molding. The reason behind the choice of processes is mentioned in the CDR report. The design and dimensions for this product were taken from the given research papers. From these, we created a mock CAD design. We then exported that CAD model as a DXF file so that we could open it as a 2D drawing in CorelDRAW. This drawing was then edited so that it could conform to the settings of the laser machine. The laser machine is fitted with a 75-watt CO2 laser with a 10 micron laser width. The challenges with laser cutting is that we cannot control the depth of the engraving directly. This can be done by adjusting the three parameters, which are speed, frequency, and power. In order to get optimal results, we had to run multiple trials, adjusting the parameters for each trial. The first trial was run at standard settings of 50% for speed, frequency, and power. The second trial, the power was then reduced to 25%. In the third trial, the frequency was increased to 100% in order to get a smoother surface finish by more laser pulses. The parameters were recorded for each trial to be later examined. From visual inspection, the first trial had a very rough and inconsistent surface finish, which was definitely not within the required tolerance range. The second and third trials showed great improvement in surface finish quality. To determine if they were within the 10 micron tolerance, they had to be measured accurately using adequate equipment. Using the mechanical department's profile meter, the surface roughness was plotted as a three-dimensional graph. From the results, it was determined that the average depth that was achieved was 100 microns at best. In addition to this, the depth was extremely inconsistent on a micro level due to the pulsating of the laser. Lastly, the channel narrows as the depth increases, which can pose a problem because the design requires a straight channel. In conclusion, more trials would need to be conducted in order to fine-tune the parameters in order to achieve the desired results using the laser machining. The CNC tooling that we purchased was a 50 micron end mill. This type of tooling requires a special connection in order to speed up the tool to really high RPMs. Due to this requirement, the prototyping cannot be done at the Bergeron machine shop, as this connection is not available. However, this connection is available at the Petrie machine shop. The Petrie machine shop charges by the hour, therefore the prototyping is delayed until we have a better understanding of the project budget. Our final method of prototyping is through injection molding. The prototyping, however, has been delayed for injection molding because the materials have not arrived yet. Furthermore, we need to manufacture the mold for injection molding as well. This will be done on a later date. Please refer to the adjusted schedule in the CDR report. In conclusion, the laser machining was prototyped. Achieving the correct tolerances is much more challenging than we initially expected. During the coming weeks, injection molding and CNC machining will also be prototyped. So far, the cost for prototyping is $180, and this was spent on the delivery and purchase of 2 micro end mills. I hope you enjoyed our presentation, and thank you for watching.